Hello and welcome back to the lab. Today on the bench we have the humble capacitor. Maybe not so humble, maybe a little bit more infamous. I'm not 100% sure. But I've gotten a lot of comments and questions about capacitor replacements, why I replace what I replace, and some of the things that go on in the lab. So, in light of those comments, because I keep getting repeated comments in the same vein, I'm going to try to answer as many questions as I can about capacitor replacements in this video. So we'll start off with capacitor replacements on some of the more modern gear that Tech has made, and then we'll move into some of the more vintage gear that Tech has made. First question I'm going to address is why I don't use a lot of axial capacitors. This is an axial capacitor that I bought for a meter, where I ended up having to use 2 radial capacitors because finding a radial capacitor with a 600 volt working DC is kind of hard. It is very difficult, if not impossible, to source axial leaded capacitors at 105 degrees C rated. Everything seems to be at 85. I have not found any yet. That is not to say they do not exist. However, I have not located any reliable source of axial leaded caps that hit a 105 degrees C rating. That rating is the internal temperature of the capacitor, not the external temperature of the capacitor. Obviously, if you have a capacitor flanked by vacuum tubes, very similar to this guy right here, externally he's going to get kind of hot. Hopefully not 85 degrees C hot, but still pretty warm. The internal temperature rating is based on the ESR of the capacitor and how much current is being pulled out of the capacitor at any one time. It's the internal heating of the capacitive elements and the electrolytic. Larger caps have a blow-off valve that if the cap overheats, this will actually expand out and the cap will outgas to keep it from exploding. And some of them, especially vintage and modern electrolytics, if they get cranky, they will explode. If you want to see this effect, I do not recommend this. I do not condone this. You should not do this. But if you wire one up backwards, they get very excited and they blow up. That is dangerous, especially with larger capacitors. They do blow up with a considerable amount of force. They can damage things. They can injure people. It truly is a mild explosion. It's there's a couple of YouTube videos from various people. You can search exploding capacitors and see what I'm talking about. I do not recommend trying that at home. One of the things that this style vintage capacitor can do that this style capacitor, modern capacitor, cannot do is have transients over voltage. This is a problem in tube gear where the B plus comes in, hits this cap hard, and for 30 seconds or so it's sitting above its working voltage. Some tube equipment can be quite high B plus, and you can be 50, 70 volts above the working voltage of the cap until the rest of the tubes come into emission and bring the power rail down. For a vintage capacitor, this is okay. It's not healthy for the capacitor, but it's also not going to hurt it. For a modern capacitor, it will damage the capacitor. The modern capacitors are not tolerant of overvoltage at all. Even a couple of volts overvoltage will build up a lot of heat in the cap, cause it to vent out. The difference between the vintage capacitor and the modern capacitor is the dielectric. In the vintage capacitor, the dielectric is actually caustic. The caustic dielectric, when they sit on the shelf for a while, it eats away the insulating layer between the two capacitive plates. However, when voltage is applied to the capacitor, it regrows the capacitive layer between the two plates. So as long as the current through the capacitor is kept at a minimum, that insulating layer can regrow and the capacitor can heal. This is what is actually happening during the reforming process of capacitors. You run a small current through the capacitor, milliamps, to keep the capacitor from overheating, and you're waiting for that dielectric layer to regrow. In a modern capacitor, there is no reformation step. The electrolytic is not caustic. It will not regrow the insulating layer. It will not eat the insulating layer. This will sit on a shelf for 50 years, and as long as the stuff doesn't dry out or the seals don't break, this will be okay. You don't want to volt slam that if you're using a vintage capacitor before, and we'll get into some of the other reasons why I'm not a fan of capacitors that have sat on the shelf for 50 years. So this will need to see some voltage, lower voltage than its working voltage, to kind of kickstart it so it doesn't just flash short when it sees B+. Obviously, if you have a 400 volt cap on a 6 volt rail, my 410B meter did that, it's not going to carry at 6.3 volts. You have a 600 volt cap on a 400 volt rail that has been off for a while, it's gonna draw some current while it refreshes itself. Why I typically go the replacement route versus the reformation route. Some of the equipment that I get in the lab is customer gear. I don't own it. Therefore, I don't make the decisions on it. It's really that easy. I will discuss with the owner of the equipment options, things like that, see what they want to do for service, see what they don't want to do for service. I do not over-service any equipment if my customers don't ask for it. I will also advise people on equipment, and I have turned down repairs in the past because equipment needed things and I wasn't allowed to give it the quality of repair that it needed. So I have had to turn down jobs in the past for the bench because it wasn't going to be up to a standard that I wanted to attach the name of myself or my business to. But I will not turn down an equipment if a customer says they want the vintage capacitors in there still. I will still probably take something in. I'm a little pickier with amplifiers and coupling capacitors because that can actually damage things. Having leaky coupling capacitors in a amplifier, especially for a gigging musician who's on the road, that piece of equipment is not reliable, and it can do very expensive damage very quickly, burning out power transformers, audio output transformers, things like that, which are much harder to replace than a couple of coupling capacitors. But I will advise the customer my thoughts as a technician, but at the end of the day, it's their device. They tell me what to do. Everything I've done has been at customer request, at minimum at discussion with the customer, or at customer instruction. It's not even a request at that point. It's not really a demand, but it's not a request either because it's their piece of equipment. They tell me how to. I tell them what the problem is, and they tell me if or how they would like to proceed with several proposed fixes. One of the other comments that I get a lot on the channel is, Tech made great capacitors. Why do you replace so many Tektronix capacitors? They made amazing caps. This is true. The Tektronix company did make amazing caps. This is a bulk filter cap. We'll pull out this 6x4, and I will turn this towards the camera. Mallory made this cap. Now, the thing is Tech did buy a lot of extremely high-quality parts at the time. They did not spare much expense, and they bought the best that there was available. The thing is, they bought the best that there was available. We're going back now sometimes 70 years in manufacturing technology, so the stuff is going to start showing its age. That is not to say modern capacitors are better than vintage capacitors or vintage capacitors are better than modern capacitors. All we have to do is look to the PC and equipment world of the late 90s, early to mid 2000s. All that stuff is notorious for capacitor failures, especially in the PC world. I cannot tell you how many motherboards I've recapped because of exploded capacitors on 98 through 2005, 2007, actually probably longer than that, 12. Let's go 12. 97 to 2012, that kind of equipment range. The capacitors were terrible. Blowing up all the time. Even in test equipment, I know Keithley gear from that time, it has a real bad problem with the bottom of the capacitor failing and electrolyte leaking out and eating the board, destroying traces, really causing horrific amounts of damage onto some of these boards. So modern in quotes is not always better. However, this is a capacitor that the Tektronix company made. This is an amazingly high quality capacitor. No expense was spared in this capacitor's construction. We're not even a very high working voltage. We're at 25 working volts DC, but it's a 9.95 microfarad capacitor, and this one's actually marked. We have another example of a capacitor that Tektronix made, and I can barely read this one. This is a 100 volt, but it's a 985 picofarad capacitor, and it's also been graded a G. Here's the set of extremely high quality capacitors from the Tektronix company. This is out of a 465B. These are used in the timing circuits. So when we talk about capacitors that actually Tech made, this is what we're talking about. These should not be touched until they are proven false. They should never be replaced. They should never do anything. These are to be considered sacred capacitors until one of them is proven bad. This isn't an ESR test. This is like a short test. This is a very far out of capacitive tolerance test because these are timing capacitors in the sweep circuit. So this is what's actually making the sweep of the scope function correctly and having the dial be able to be lined up. And these capacitors were hand-selected, hand-graded, and hand-picked for each unit and also sold as a set. You can't buy one of these caps individually. If one of these caps failed, you replaced all of them in the scope to make the front dial work correctly with the A and B sweeps. So if you're working on a 400 series scope or a 7000 series, well, any scope really, the timing caps, unless they are proven bad, leave them alone. It'll cause all kinds of nightmare trying to line up the front dial if these ratios get out of work, or get out of alignment. And you'll notice some of them are labeled J+, some of them are labeled G-. So the ratios of the capacitors are actually what's important and what to get the front dial to line up for the time per division. Also, if you are restoring vintage gear and you like the vintage look and want to go back with vintage capacitors, the company bought all of the electrolyte solutions, the machines and everything, and brand new Mallory multi-section capacitors are hitting the market. Not new old stock, new manufacturer. All the old equipment, all the old machines, things like that. So if that's the way you want to go with the build, that's now available again. They're still spinning. At last I checked, they were still spinning up production. So I'm not sure what the availability is yet, but these multi-section can caps, we can get new, at least at the time of this recording, we can get new manufacture on those. Here are some small power filtering caps that I pulled out of a random Tech device. Again, these were not made by Tech. These were made by Sprague. And I'm not saying anything bad about Sprague or Sprague, especially some of their big power lytic caps, the big ones. They're great capacitors, and they run for a very, very, very long time, the ones that have the screw terminals and things like that. One of the things I've started noticing on these smaller caps is every capacitor, including the modern ones, they're sealed with a rubber plug at the bottom. Well, it's rubber. The rubber on car tires and stuff doesn't last forever. Rubber doesn't last forever. I'm starting to see capacitors come through the lab where this rubber is starting to crack and split and break and things like that. Electrolyte hasn't started leaking out yet, but air ingress into the capacitor or electrolyte exiting the capacitor is shortly behind. So in some of those ways, the packages are physically failing before they're electrically failing. But for a longevity of a repair, a capacitor is relatively inexpensive, so I just replace it. or I do what the customer tells me, but I do replace it. One of the reasons I recommend replacing the capacitors is a lot of the reasons people send gear into the lab is because they don't have the calibration gear necessary to check the device after it's been repaired. Now, if a capacitor is failing and the power rails change, that's going to throw off the calibration. It's going to need some adjustment. And one of the reasons people send things into the lab for me to fix them is they don't have a 7.5 digit meter, a AC/DC calibration suite available to them, even to take it somewhere and borrow. They would have to send it off to a cal lab to get it fixed. Nor am I recommending anybody take that dive unless they really want to and create and have a bunch of gear that they need to service. One of the reasons why I did the calibration dive is because of just how many different plug-ins, meters, and things like that I had to fix to service to get them operational, because I need them to tell me accurate information on the bench so I can service other people's equipment. So it doesn't help if I have a functioning meter that's lying to me that doesn't have a good calibration on it. I need a functioning meter that's telling me accurate things within its tolerance and has a good alignment on it to be useful on the bench. Because it could send me down a rabbit hole with a red herring if say I'm measuring a 5-volt rail and the meter's misaligned and it's telling me it's 2 volts low. Well, that could throw the rail out of tolerance, especially on some of this test equipment. The tolerance specs on the power rails are very, very tight, which actually causes tech some problems as you get into the later equipment. So one of the things the 400 series scopes in tech and later the 7000 series and things like that are known for is blowing tantalum capacitors. Well, here's a little bit of a golden nugget. It's not the tantalum caps that are the problem. It's actually the electrolytic caps that are the problem. So tech made a poor design choice, and if they had a 15-volt power rail, sometimes they would use a 16-volt tantalum capacitor. That's cutting the rail a little tight, especially for a tantalum capacitor. They get kind of cranky. So the problem is when the bulk filters start to fail, you get a little bit of ripple on the rail. Get enough ripple, and all of a sudden you're going to go over the rated voltage of the tantalum capacitor. Tantalum capacitors, even vintage ones, have never liked being overvolted. They get very cranky about that, and they tend to short out and blow up. So that's why some of the 400 series stuff is showing tantalum capacitor failures, is because the ripple on the rails is a little high because the bulk filter caps are starting to struggle. So the ultimate problem is the electrolytics, not the tantalums. That is not to say the odd tantalum's not just going to up and fail, but if you have a couple of failed tantalums in a piece of equipment, especially around that 400 series, 7000 series, 5000 series time frame, definitely put a microscope on all the power rails, make sure the ripple's good, and if you have to, do some capacitor replacement. It'll smooth it out, won't be a problem. The 2000 series scopes, I have yet to get one of those in front of the camera. I am looking to get one of those in front of the camera to do some restorations and calibrations on those, but those are known for capacitor leakage of the surface mount electrolytics. But we're getting into that mid to late 90s to 2010 time frame where it got bad with the 2000 series scopes, because I didn't realize it. But the 7000 series scopes got us into the late 90s. I mean, we still had, the 7000 series was still in production, I think up to 98, if I remember correctly, maybe a little bit longer. So, not bad. Now, the other thing is, this is a board out of a 7854, not the 7854 that's on my bench, the one that I have in the corner that's busted because the shipping people dropped it. However, we'll notice these aren't Tektronix capacitors either. These are Nishikans. Now, these little blue ones, which I replace a lot, they are Nishikan capacitors. They are good capacitors. However, they're 85 degrees C. So it's never going to hurt anything to refresh these capacitors, but also bump them up to 105 degrees C cap, due to the fact that these scopes run hot. It's It's kind of bonkers how warm some of these scope gets, and the tube gear gets even warmer. So a 7854, let alone a DSA 602, they get real toasty. The DSA 602 has 320 millimeter high flow fans in the back. Sounds like a jet engine when I turn the scope on. These caps are sweating while they're doing their job, packed into this equipment, and this is one of many boards that slot close together. So there's not a lot of airflow between these boards. So everything on here, including all this logic, is baking. It's getting pretty toasty. So airflow is definitely, well, heat's the enemy for everything. So the cooler I can keep something, including in the modern stuff, the better. It just makes it live longer and last longer. So one of the reasons why I replace, well, a big reason why I replace capacitors in customer gear, and I'm more aggressive with customer gear than I am with my own, because if a piece of equipment fails on my bench, it's inconvenient. If a piece of equipment fails on my customer's bench, they have to box it up, ship it back to me. I have to get it, I have to evaluate it, I have to fix it, I have to calibrate it, I have to box it back up and send it back to them. And they can be without it for a while. So for my customers, it's very inconvenient to have me repair something and then have that repair not have staying power. So to give the repairs the best chance I can for staying power, I'm fairly aggressive with the capacitor replacement because it's relatively cheap insurance. Now when you get to capacitors this size, they start getting a little pricey. I think this one was in one of the curve tracers. I think the 15,000 was on the 5-volt rail. Just giant cap filtering the 5-volt rail on those. But so it's a longevity of repair thing for my customers. So we are a little bit more aggressive, but that's so the unit stays in service on their bench the longest. So I hope that explains some of the thought processes and the reasoning and things like that behind some of the things you see on the camera. I have gotten some requests to show some more of the actual capacitor soldering work. Apparently that's a thing people want to see, so more of that will be coming in future videos. And if you like the comment, found it informative, is that a word? Informative, stick around and hit the subscribe button. As with all things, this video was comments generated, so I read all the comments on every video, and I see everybody in the comment section between videos. So I will see everyone in the comment section, and stick around. More is always on the way.